CISS stands for the Chiral-induced spin selectivity. This effect deals with electrons. Electrons are transferred in all living organisms, plants, animals, and human beings. The electron transfer process allows to transfer energy and information from one place to another in the organism. Therefore, an efficient electron transfer is essential for life. Hey, who turned off the light? Electrons are conducted best through metals or metal-like organic molecules. However, in bioprocesses, the electrons are conducted through protein, as you see here. Proteins are as far as possible from metal in their electronic structure. When electrons are conducted through metals, they can be scattered back. This makes the transmission inefficient and heat is produced. The question is, why evolution has evolved to use chiral molecules that are proteins for electron conduction instead of wire-like molecules? The research we describe here is attempting to answer this question. Let me introduce the main actors, chirality and electron spin. Electrons have two important properties. They can carry negative charge and they can have spin. The spin is the angular momentum of the electron, like a rotating top. Like a top that can rotate clockwise or counterclockwise, so the spin can have two values, many times referred to as spin up and spin down. The spin is also associated with a magnetic dipole. How chirality of molecules and spin are related? Here we will introduce the CISS effect. When electrons are moving through chiral system, they feel as if there is a magnetic field acting on them. This effective magnetic field acts on magnetic dipole of the electron, namely on the spin of the electron. Therefore, when electrons are transferred through chiral molecules, one spin is preferred over the other. While regularly the electron can have either spin up or spin down with the same probability, when the electrons are transferred through chiral molecules, only one type of spin is preferred, so chiral molecules are like spin filter. This is the chiral-induced spin selectivity effect. Which spin is preferred for being transmitted depends on the handedness of the molecule, right or left hand-like symmetry, and on the direction of motion. This means that electrons cannot scatter back without flipping their spin. Flipping spin is highly improbable. So, for each chirality, one spin is transferred and the other is left behind. Since in bioprocesses, electrons have to travel relatively long distance with very high efficiency, and the electron transfer should go always in one direction, we see how the CISS effect can be important. Again, electrons cannot be scattered back by anything, even when molecules are moving in the thermal bath of the environment. Therefore, the transferring of electrons is efficient and directional. Hence, a possible answer to the question posed is that nature picked proteins because they are chiral and therefore allow electron transfer through them in a very efficient way. Now it is up to the scientific community to probe the role of spin in bioprocesses. Thank you.